This is a hard disk drive, but you already knew that. It's been the backbone of the world's digital infrastructure for so long that it's practically invisible. Maybe that's because it looks so simple on the outside. But as they say, it's what's on the inside that counts. Using some of the most complex nanoscale engineering and material science on the planet, this is where the majority of the world's data is stored. The real work that happens in a hard drive is at the atomic level, so small that we're now measuring length in angstroms, as in the units of atoms themselves. On top of that, the timescale we're using here is in the trillionths of a second, a picosecond, and it all starts with a little digital dialogue. The brains of the operation is a cutting-edge nanoscale chip, rapidly moving data with finely tuned processors and custom algorithms. Using millions of lines of code and some of the most complex hardware logic ever designed. 4 billion bits of information are perfectly decoded and orchestrated every second. Now, it's one thing to choose the right data at the right time. Actually recording it in the right place takes a touch of nano-robotics. These read-write heads move back and forth while maintaining a space of just 10 angstroms from the disk. That's about 3 water molecules. Not droplets, molecules. Plus, they do that while flying on a data track with a precision of less than 3 nanometers. Just a bit of magic, right? Okay, let's put that level of precision like this. Imagine traveling along at 80 miles per hour and never drifting more than 15 atoms to either side. Once you've got that down, do it with your eyes closed more than 95% of the time. Below you, a bit races by every nanosecond on a spinning surface with nearly 600,000 tracks, each one 2,000 times thinner than a human hair. But shrinking the bits further comes with a challenge. When you get down to nano dimensions, the recording material becomes magnetically unstable. To solve that, we need a storage layer with higher magnetic coercivity than today's drives. So, we came up with a groundbreaking new material made with a superlattice structure where every single atom is set exactly into place. Still with us? Good, because we're just getting to the cool part. The thing about writing on this new material is that you need to heat it up to over 800 degrees Fahrenheit, then cool it back down in an instant. And by instant, we mean less than 2 nanoseconds. To do that, we don't just bring in a laser. We guide the light to a plasmonic transducer. These 3-dimensional nanoscale structures combine to generate an electric field on the disk, heating an area no bigger than a single bit. With the data stored, all that's left to do now is retrieve it. Easy enough when you have the world's most sophisticated magnetic sensor helping you out. A magnetic sensor based on Nobel Prize-winning tech, that is. And if you think that's hard to wrap your mind around, don't forget that all of this is happening with not 1, but 10 disks, spinning 24/7 for years inside the data center. This is post-nano engineering. This is where the future is read and written. But, you know, it's just a hard drive.